Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. In resonance, canonical structures, we evaluate their validity based on formal charges, electronegativity considerations, and octet rule compliance. A canonical structure is considered practically invalid if it places a positive charge on a more electronegative atom and a negative charge on a less electronegative atom, violating electronegativity principles. Moving on to the next step. Analyze structure ICH2 is equal to O. This is the neutral Lewis structure of formaldehyde with AC is equal to O double bond. Carbon and oxygen both satisfy the octet rule. Carbon has 4 bonds, oxygen has 2 bonds and 2 lone pairs. This is the most stable and valid canonical structure. Moving on to the next step. Analyze structure 2 plus CH2O-. Here carbon bears a positive charge and oxygen bears a negative charge with a single CO bond. Since oxygen is more electronegative than carbon, it is perfectly acceptable for oxygen to carry the negative charge and carbon to carry the positive charge. This structure is a valid, though less stable, canonical structure because the negative charge resides on the more electronegative atom, oxygen. And for the final step, analyze structure 3-CH2O+. Here carbon bears a negative charge and oxygen bears a positive charge with a single CO bond. This places a negative charge on carbon, less electronegative, and a positive charge on oxygen, more electronegative. This violates the basic electronegativity principle. A more electronegative atom should not carry a positive charge while a less electronegative atom carries a negative charge. Such charge separation is energetically very unfavorable and makes this structure practically not a valid canonical resonance contributor. Why other options fail? Structure I is the primary valid structure. Structure 2 is a legitimate resonance contributor. Structure 3 is the one that violates electronegativity principles and is therefore practically not a valid canonical structure. Therefore, the correct answer is C. Therefore, the correct answer is option C.